got to start by identifying what procedure is taking place here. What is happening? You multiplying bases? Are you dividing bases? Are you raising powers to powers? How do you raise a power to a power? You multiply the two exponents together. Now, trigger your brain to think about radicals. Can I multiply the square root of 2 times the square root of 3?
Yes.
What do you get? The square root of 6. Now remember, when we worked with radicals, every time we get a final radical, we need to make sure that it's simplified. So now, just because it's in an exponent, that does not change. We've got to look at the square root of 6 and ask ourselves, can we simplify this? And the answer is no. Can't pull anything out of the square root of 6. So your final answer is 2 raised to the square root of 6. All right? Somebody tell me what you think that answer is.
2 to the 7th.
2 to the 7th. I knew I would get 2 to the 7th.
2 to the 7th power.
It's
No,
4
two-
to the 2
two-
square roots of 7. 4
Yeah.
2 square roots of
How do you
7.
say that?
It's not 4.
4 to the
Okay,
7th power.
listen.
Well, 2 to the 2 square roots of 7.
It's actually 4 to the square root of 7. And I'll show you why. First off, see, Jordan, I knew you'd say that because first hour said the same thing. You see square root of 7, and you automatically think 7. Because when you square it, that's what you get. But you've got to think of your exponents. I am multiplying the bases, which means I need to add the exponents. The exponents are identical, so I'm adding 1 plus 1 to get 2 square roots of 7. And the base of my expression is 2. Now, anytime your radical can be simplified and a whole number winds up out here, this is the same thing as 2 squared to the square root of 7 power, is it not? You can square the 2. All right? If you can square that number, if you can do that operation, you need to do it. And this is why the final answer was 4 raised to the square root of 7.
So why wouldn't you just multiply the 2 and 2?
Because I'm combining by working with the exponents. I can't multiply the 2 and the 2. Okay? I mean, it looks like it would have worked out that way. But if it wasn't a perfect 2, it would have gotten something completely different. It's just that your 2's fool with your brain a little bit. All right. Now watch what happens here. We're going to figure out and simplify this expression. 81 to the square root of 2 divided by 3 to the square root of 2. Now there are things we need to think about. Before I can start saying, okay, this is division, I need to subtract the exponents. What's the problem?
They're not the same base.
The bases are not the same. In yesterday's lesson, we learned how to turn the bases the same, or make them the same. Okay? We need to take 81 and make it 3 to the something power. Well, what is 81 as 3 to the what?
4th.
3 to the 4th power. Now 81 is being raised to the square root of 2. So a power raised to a power, how do I do that? You multiply. And 4 times the square root of 2 is 4 times the square root of 2. Now, before you're tempted to say, oh, well then turn this into 81. We're trying to simplify. If we turn this into 81, we're just right back where we started. The reason we made the bases identical is so that we could combine the two bases to get a final answer with only a single 3 and its exponent. Laws of exponents. When you are dividing, you subtract the two exponents. So that's 4 minus 1 square roots of 2. Now, in your final answer, can you take this a step further?
Yes.
Since the 3 is a whole number, you can actually cube. 3 cubed is 27 to the square root of 2. Was the final answer. So we basically looked at all possibilities here. What happens when you multiply them? When you raise a power to a power, when you divide them. And then what happens if the bases aren't the same? You've got to make them the same. Because none of those rules apply if the bases aren't even the same. All right? Okay. That's today's lesson.
Let's see where graphing it is. Why don't we leave them anyway? So like the entire weekend.
We're not going to get into graphing. Okay?
It's a waste of time.
It's not a waste of
It's a waste of
time.
time.
It's
We're
just
never
we're
gonna
not
use
going to get into graphing.
It takes
No,
no
it's
time.
not that. You're going to touch it next year. And we're actually supposed to be using graphing calculators to do it. And I haven't required you to have graphing calculators. So, there we go. So that's today's lesson. Your homework is page 525, numbers 39 through 44, all of them. That's not much. You have time right now to finish your homework in
Can
class.
I turn it in the end of class?
Yeah, Miss Sally.
Can we turn it in the end of class?
I'm sorry, page 528, 39 through 44, all.
It's on. You know you can use Bluetooth on your computer. What?
That's what she said. I don't know how it's in
50-point test on Monday
How's it look like anything?
on this section, section 10-1.